Okay guys, welcome to another episode of Pinoy in Australia. So today we're going to discuss about oxygen sensor. So what leads me to discuss about oxygen sensor? We have one follower in our YouTube channel. He's asking about oxygen sensor because he got a Nissan X-Trail and it has a hard starting issue. He's asking whether the oxygen sensor can cause hard starting. So let's discuss first what are the two types of oxygen sensor. So the first oxygen sensor that produced by automotive manufacturer is what we call the narrowband oxygen sensor. Narrowband oxygen sensor use voltage to monitor the air fuel mixture on the to control the fuel trim in the system, so in the engine. So it analyzes the exhaust gas that coming out from the combustion chamber, and by analyzing it, it will determine whether there is a rich or lean or perfect air fuel mixture being fed inside the combustion chamber. So the next one is the wideband oxygen sensor. Wideband oxygen sensor uses current to monitor and to distinguish the quality of the exhaust gas being produced by the engine. So it uses ampere to tell whether the combustion is on, the air fuel mixture in the system is rich or lean or in perfect condition. So let's talk about first the narrowband oxygen sensor. We will create another video about wideband oxygen sensor. So let me just demonstrate first to you something so we can easily analyze the combustion process and how the oxygen sensor analyze the exhaust gas. So I have piece of tissue inside this container, this gas container. I'm going to set fire this piece of paper, this tissue. So, as you can see, the fire is consuming the paper. Once I close the lid, the passage of the air on the container, immediately the fire is distinguished. So let me do it again. Okay, it's caught on fire. We're going to cover the lid. Oh, nailed it. Shut. Let's cover it. See, the fire extinguished. So what is the reason why the fire is extinguished? The reason why the fire is extinguished is because when we cover the lid, we put lid on the container, the passage of oxygen is cut off. So we need oxygen to set fire a material. So same thing in fuel. If we're going to put on fire the fuel or the petrol or the gasoline, we need oxygen to burn the fuel, the oxygen or gasoline. So in petrol engine, 14.7:1 is the perfect ratio that is required so the engine can produce the proper power to operate the engine. So if the 14.7:1 become imbalanced, either will become rich or lean. So 14.7 is the amount of air, and 1 is the amount of fuel. So let's take, for example, we have bridge condition. If the ratio become 12:1, 12 air and 1 fuel, that is rich condition. So let's take a scenario, lean condition. Let's say we have 15:1, 15 air and 1 air. One fuel. 15:1. 1 is the fuel, 15 is the air. So what we have there is lean. We have heaps amount of air to our air fuel mixture. So it is programmed to the memory of the computer that 14.7:1 is the perfect air fuel mixture, and it should always have 14.7:1 so the engine will operate smoothly. So I'm going to pull out a drawing so I can explain to you much better what happened during the combustion and how the oxygen sensor analyzed the exhaust gas. Okay guys, I have a graph image here. Usually this is what you can see on the scan tools on graph mode. And this is also what you can see in the oscilloscope if you're going to use oscilloscope reading the voltage being produced by the oxygen sensor. So oxygen sensor produce voltage when the oxygen sensor is exposed to oxygen, and the oxygen sensor can produce from 100 millivolts or 0.1 volts up to 900 millivolts or 0.9 volts. If your reading will go to 1 volts, the scan tool will produce fault code. If your oxygen sensor produce 0 volt, it will produce fault code also. Because the normal operation of the oxygen sensor is 100 millivolts to 900 millivolts. Usually in scan tools, if you're going to go to the parameters and you will set your scan tools into graph mode, you can see that there will be a waveform from 100 millivolts going to 900 millivolts. It continues up and down, up and down, and up and down. So that is the normal operation of oxygen sensor. From here, see 14.7:1, that is the normal that is the normal air fuel ratio of petrol engine or gasoline engine. Everything from here going up is rich condition. Everything from here is lean condition. 14.7:1 is equivalent to 500 millivolts. So if you are reading 500 millivolts, you are in perfect fuel ratio, which is 14.7:1. So let's discuss a scenario. Also the relationship of oxygen sensor and into the fuel trim. So the example that we have a broken intake manifold gasket. So let's take a drawing. So let's say this is our engine. This is cylinder 1, 2, 3, 4, 5, 6, and this is our intake manifold. This is our throttle body, and this is our air filter. Let's say our intake manifold gasket is broken. So during intake stroke, the cylinder will suck air in the intake manifold. What happened when it suck air? It suck air from the broken part of the intake manifold gasket, and that air going in the intake manifold gasket will be unmetered air. So our 14.7:1 air fuel mixture will be imbalanced because there will be more air coming inside the intake manifold into the combustion chamber because of the air leak here coming from the gasket. So unmetered air. So we call it unmetered air because the air doesn't pass through the throttle body. The throttle body is the one that meter the air that coming into the cylinder. So once you have unmetered air in there, it will become imbalanced. The 14.7 will become imbalanced. So the amount of air will be larger compared to the gas. So the oxygen sensor, the upstream oxygen sensor will detect that there is imbalance in the air fuel mixture. So what the oxygen sensor will do is it will inform the ECM and it will say, hey computer, our air fuel mixture is imbalanced, we have so many air. So what will computer do is it will produce positive fuel trim. For example, a large air leak in the intake manifold require, for example, 20% positive fuel trim in order to bring up the fuel trim to 14.7:1. For example, we're reading 200 millivolts. So let's pretend that we need positive 20% fuel trim in the short-term fuel trim to correct the ratio to bring up this 200 millivolts to 14.7 to 500 millivolts, which is 14.7:1. So by adding positive percent fuel trim, it means positive fuel trim is opening the fuel injector on longer time. So the longer the injector opens, the more fuel will go into the system. So once for example, we need 20% to correct the air fuel mixture, it will produce positive 20%. This reading will go to 14.7:1. So let's say we have a red scenario. Let's say we have sticking fuel injector into open. So what will happen is we are going to have, for example, 800 millivolts. So that's enriched condition. So that 800 millivolts need to bring down to 500 millivolts to acquire 14.7:1. So let's pretend that in order to bring down the 800 millivolts to 500 millivolts, which is 14.7:1, it requires negative 20% fuel trim in short-term fuel trim. So once the fuel trim goes to negative 20, it will bring down the graph into 500, and that will go to 14.7:1. So it will go to perfect fuel air ratio. So the normal operation of the air fuel sensor is the oxygen sensor is go from here, from point 1, it goes up, it goes down, it goes up, it goes down, it goes up, it goes down, it goes up, it goes down. So that is the normal operation of oxygen sensor, auto sensor. So once there's a stuck fuel injector stuck open, it will, for example, it will read 800 in stuck in the top. Or if you have broken intake manifold gasket, it will stuck the reading into 200 millivolts. So let me repeat it again. If, for example, you have stuck open fuel injector, it will read 800 millivolts. It will stuck in 800 millivolts. If you have a broken intake manifold gasket, it goes to 200
millivolts.
Like that. In some scan tools, it will read like that. Then it goes short. Then much longer time stay on the 200 millivolts. So the computer will correct the imbalance air fuel mixture by adjusting the fuel trim. So fuel trim is the time, the opening of the fuel injector, either positive or negative. If you said positive fuel trim, it means the injector is open in much longer time. If you have negative fuel trim, the opening of injector will be in shorter time. So we're talking about the opening time period of the fuel injector. So that's how the relation of the fuel trim and the oxygen sensor. So oxygen sensor is located in two areas. So let me show you the diagram. So let's say we have 6-cylinder engine. So for example, this is the arrangement of the cylinder 1, 2, 3, 4, 5, 6. So this will be divided into two. This will be your bank 1 and this is your bank 2. So in your scan tool, you will find oxygen 1 bank 1, oxygen bank 2 number 1, oxygen bank 2 number 2, oxygen bank 1 number 2. So what is oxygen bank 1? Oxygen bank 1 is anything on the side. So 1, 3, and 5, that is your cylinder 1, 3, and 5. That is your bank 1. Let me correct myself. Cylinder number 1, 3, and 5, that is your bank 1. Cylinder 2, 4, and 6 is your bank 2. So if you have 4 oxygen sensor, some vehicle use 4 oxygen sensor, some use combination, 2 oxygen sensor, the narrowband, and 2 wideband oxygen sensor. So let's say that we're using 4 narrowband oxygen sensor. Oxygen sensor that plays near the exhaust manifold. This is your exhaust manifold. This is your engine. That's called upstream oxygen sensor. Oxygen sensor that is placed after the catalytic converter. That is your downstream oxygen sensor. So upstream oxygen sensor, the function of that oxygen sensor is to monitor the quality of the combustion gas that come out from the cylinder. And so if there is imbalance ratio on the oxygen air fuel mixture, by analyzing the gases that coming up from the combustion chamber, it will tell the computer to adjust the fuel trim to correct the air fuel mixture. So that is the function of the upstream oxygen sensor. While the downstream oxygen sensor, the main function of the downstream oxygen sensor is to monitor the performance of the catalytic converter. So catalytic converter process the exhaust gas coming out from the engine into a lesser harmful gas. So the catalytic converter is like a hot oven, and it burn the unborn fuel in the exhaust gas. So if this catalytic converter is functioning properly, your reading on your bank to the reading of your oxygen sensor on downstream supposed to be lean. So if your oxygen sensor is really reading rich, it means there is something wrong with your catalytic converter. So usually in first start, if the catalytic converter is still cold, your catalytic converter will produce same amount of gases on the compared to the gases that coming up from the combustion chamber, because when the catalytic converter is not yet hot, it means it's not yet working. So it needs to become warm before it does its job. So once the catalytic converter become very hot, it should produce lean value of oxygen sensor voltage. So usually it will produce around somewhere 700 millivolts once it processes the exhaust gas, because the process of the purpose of the catalytic converter is to improve the emission that being produced by the engine. So you can diagnose your catalytic converter whether it's still working using these controls by monitoring the downstream oxygen sensor. Guys, let's go back to my graph. So we're going to discuss the relationship between the air fuel mixture that we fed on the in the combustion chamber and the exhaust gas that it will produce during the combustion, and also the relationship of oxygen sensor to the fuel trim. So oxygen sensor is designed to produce 100 millivolts to 900 millivolts. So when the engineer designed the engine with what we are discussing right now, what we are repairing right now is a perfect engine, a brand new one with perfect compression with no leak, no problem with the piston ring, with no problem with the valve. So perfect compression. So when the engineer calculated that 14.7:1 is the perfect air fuel mixture, that if you put this one inside the combustion chamber, they had calculated that this 14.7:1 air fuel mixture will produce the proper combustion that will produce the proper force to operate the piston, so the vehicle will operate smoothly. So they know that this 14.7:1 air fuel mixture, that if you feed this one inside the combustion chamber, the emission that it will produce will cause the oxygen sensor to produce a voltage of 500 millivolts, which is perfect air ratio. So perfect air ratio is equivalent to 500 millivolts. So if you bore this air purification will fit inside the combustion chamber. Once it born inside the combustion chamber, it emit emission, and that emission will make the oxygen sensor to produce 500 millivolts. So during 900 millivolts, that is the maximum voltage that the oxygen sensor can produce. That 900 millivolts is equivalent to 11.8:1. So if you feed 11.8:1 air fuel mixture inside the combustion chamber, and once the combustion chamber process that air fuel mixture, it will produce an emission that will make the oxygen sensor to produce 900 millivolts, and that 900 millivolts will be recognized by the computer as a reach condition. So let's go to 100 millivolts. If we put 17.6:1 air fuel mixture inside the combustion chamber, the vehicle will produce emission that will cause the oxygen sensor to produce 100 millivolts, and that 100 millivolts will be recognized by the computer as a lean condition. So that is the relation of the exhaust gas and the air fuel mixture that we fed inside the combustion chamber, and that's how the oxygen sensor interpret whether the gas that's emitted by the vehicle is rich or lean. So the next step that we're going to do guys, is we're going to hook up a scan tools into my Nissan X-Trail, and we will evaluate the actual parameters of the vehicle, and we're going to observe the fuel trim and the oxygen sensor. Okay guys, we are inside my vehicle and in my Nissan X-Trail, and I hook up the scan tools. So I pull out the parameter feed of fuel system status. So as you can see, there is an OL that means that is open loop. It means that the computer is not yet using the oxygen sensor for the fuel trim. So when the oxygen sensor is still cold and the temperature of the engine is still cold, the status of the fuel system is still on the open loop. So what it does mean is it's using the program memory inside the computer that the vehicle need to run in high RPM, so the engine will reach its operating temperature as soon as possible. So let's start the engine. Okay. So right now we are still in open loop. So the graph below is our oxygen sensor voltage bank 1 sensor. That is sensor number 1, bank 1. The other one is sensor number 2. So as you can see, the one in the bottom, the oxygen sensor in the bottom is reading lean. Okay. So oxygen sensor upstream and downstream are not supposed to be the same, because they have the same purpose. they have different purpose. So as you can see, the temperature is 43 degrees and the engine RPM is somewhere in 1100 RPM. So our speed is a little bit high right now because the engine is the computer is trying to warm up the engine. So it's not reach the operating temperature yet. So right now the fuel system is already in closed loop, so it's CL, so it means that the computer is already using the oxygen sensor to adjust the fuel trim. Okay. Sorry for the noise, guys, because I turn on the air condition. And right now, short-term fuel trim, let's put it into graph. So it's in graph. So right now you can see it's somewhere in 0 degrees, 0%. So there's a little bit of correction, so it's deducting fuel, possibly because the engine is still cold. So our long-term fuel trim is on 3.1%. So it's very hard to find a vehicle that have a perfect 0%. Usually, especially if your vehicle is already somewhere in 10 years, 15 years, you will see a little bit adjustment there. In my vehicle, it's already adding 3.1% of fuel. That is the one. So it's compensating the wear and tear that happened to the engine. So 3.1. Even brand new engine, you cannot find 0%. There is no such perfect engine that will produce long-term fuel trim 0%, because there's some kind of some kind of little bit error when they manufacture the parts, and fuel trim is trying to compensate those error. So right now the RPM is in 787, so we are on the normal operating speed of the vehicle during idle. Okay. Right now our long-term fuel trim is in 3.1. That is fixed, so there's nothing we can do about that. That's okay. 3.1%, that's fine, as long as your long-term fuel trim will not read much higher than 6%, because I've seen some of them are 6-7%, and that's fine. If you go more than that, there's a little bit problem in your vehicle, and the computer is trying to compensate it. So right now, as you can see, our short-term fuel term bank 1 is on almost 0. See? Almost 0. Almost perfect. Yep. And our oxygen sensor is, let's put it into big graph. Yep. So that is our oxygen sensor. That is the normal operation of oxygen sensor. It goes up, it goes down, it goes up, it goes down. So it read almost 0 and almost 900 900 millivolts. See? So if there is a problem in your example intake manifold gasket, what you will find is this graph will stay somewhere here in this area. So that area is lean condition. So somewhere is the perfect 500 millivolts, which is the 4.7:1 air fuel ratio. So right now I'm a little bit happy because my oxygen sensor is somewhere almost perfect. As you can see, it goes to somewhere in 100 millivolts going to 900 millivolts. It goes up and down, up and down, and up and down. Okay, but it stay much longer. See the graph? It stay much longer on the bottom, which means lean condition. So that's why my long-term fuel trim is adding around 6, I think 3% when we look at last time, because of this wave here in the bottom. So the reading is staying a little bit longer on the bottom. See, compared to the top, there's a sharp point in the top, but in the bottom there's a larger space. So it means that our oxygen sensor is reading a little bit lean. That's why in the long-term fuel trim, it's adding 3% of fuel in the system. So that kind of reading, guys, that's normal. You don't have to worry about that kind of reading. But if you reads tremendous downfall of the wave into somewhere near 100 millivolts, so it means that you have lean condition. And if your wave goes near on 900 millivolts and stay more longer on 900 millivolts, it means that you have a rich condition. This graph, guys, this is fine. So let's check our, this is our, that is the first one that we seen, is that is the bank 1 oxygen sensor number 1. So that is the upstream oxygen sensor, and this one is bank 1 oxygen sensor number 2. That is the downstream. That is the one monitoring the performance of the catalytic converter. So let's put into waveform or graph mode. Let's make it larger. Okay. As you can see, guys, the reading of my oxygen sensor that monitoring the catalytic converter is almost on right now I think it's on the somewhere in 200 millivolts, because this line here, that is 319 millivolts. That is 0.3 volts, 3.319 volts. So in millivolts, that is 300 millivolts. So maybe it's that somewhere in 200 millivolts or 250. So it's reading lean. So if your oxygen sensor located on your after the MAP sensor is reading that value, it means that your catalytic converter is in good condition. There is no way that the bank 1 oxygen sensor or upstream oxygen sensor and downstream oxygen sensor will have the same value, because their function, their purpose is different. See guys, that's the upstream, it's making a waveform, and this is our downstream. So they're not the same. So if you see them the same, so there's a problem with your engine, or there's a problem with your oxygen sensor. So right now our engine is running 362 RPM. That is our normal engine idle speed. So our long-term fuel term is 3.1%. It's adding 3.1%. So because see, the oxygen sensor is staying a little bit on the lean condition, but there's nothing to worry about that, guys. You cannot find perfect value on long-term fuel term, even a brand new engine. So right now the short-term fuel trim is almost zero, so -3. That's a perfect, guys. So it goes to zero. See, it moves to -0. So that's good, guys. It means you have a good engine. See, almost zero there. If you've seen that kind of value, that's good. It's turning to zero, it's shifting to zero. As long as you see it shifting to zero, that's good, guys. Okay, up yep. Our engine coolant right out is 79 degrees centigrade. So our engine is already warm, it's already on operating temperature. So our fuel system is already in closed loop. So closed loop means that our fuel trim is now managed by the oxygen sensor. Unlike when you see that's open loops, you see EP OL means open loop. It means that the engine is not using yet the oxygen sensor, and it's using the program value fuel trim in the memory computer to warm up the engine. That's the reason, guys, why when you start the vehicle early in the morning, your engine RPM is somewhere in 1200 RPM or 1300. Then as the vehicle become warm, the engine RPM drops down up to 700 or 750 RPM. Depend on the specification of the vehicle. Not all vehicles have the same engine idle RPM. So depending on the vehicle, you can see that one on the owner's manual. So right now we can see that this Nissan X-Trail is in good condition. Okay, guys, this is my message to our friend, my YouTube follower that asking about fuel trim, because what happened is his Nissan X-Trail is experiencing hard starting, and he brought his vehicle to mechanic and he scanned the vehicle, and both mechanics says the upstream oxygen sensor and the downstream oxygen sensor supposed to have the same value. That's the mechanic told him. So this is my answer to you, friend. Upstream oxygen sensor and downstream oxygen sensor are supposed to have different voltage value. Why? Because their purpose is different. The upstream oxygen sensor is monitoring the quality of gas coming out from the combustion chamber, so the engine will maintain the 14.7 air-fuel mixture ratio, while the downstream oxygen sensor located after the catalytic converter, the purpose of that sensor is to monitor the performance of the catalytic converter. So if your oxygen sensor located in the after the catalytic converter is reading lean condition, it means that your catalytic converter is working fine. But if the reading of the oxygen sensor downstream monitoring the catalytic converters is reading rich, it means there is something wrong with your catalytic converter. Possibly your catalytic converter is already black. So if you have black catalytic converter, you are going to have a hard starting issue because the exhaust gas cannot easily escape from the exhaust manifold. So if you block the exhaust manifold, so the performance of engine will not be good. So maybe hard starting, you will experience hard starting, and if the condition of your catalytic converter will become worse and it will totally block, your vehicle won't run anymore because it cannot dispose the exhaust gas. So to our friend, to our YouTube follower on my YouTube channel, so that is my answer to your question. So I hope you learn on this video that I have done. Okay guys, if you like this video, please press the subscribe button, and please press the like button, and please press the notification bell so you will be notified every time I do a brand new video. So in the future guys, I'm going to make a video about wideband oxygen sensor. Then after that, I will do video how to diagnose accurately a defective cylinder head gasket. This is one way guys to diagnose whether your cylinder head gasket is faulty. So watch out guys for that video. Okay guys, ciao, see you on the next video.